Boxwood bushes are beloved for their versatility. From hedges to topiaries, these bushes can be shaped into almost anything. In this tutorial, we'll apply SpeedTree rules to this model, supercharging it with shape-shifting capabilities. You can find the starter code as well as the base model in the description so that you can follow along with me. You can also find the finished model if you want to take a look around. Okay, let's jump in. If you haven't already seen our Introduction to Rules video, I'd recommend checking that one out first because we'll be pulling on concepts from there in this tutorial. Also, just to note, we're working on a VFX boxwood, so as we're working, we'll have a pretty high poly count, but you could modify concepts from this tutorial to apply to a game's model. But with that said, let's get into it. I've already written the randomize and season rules for you, so we're going to dive right into working with shape control by writing the prune shape rule. So, looking at our shape control, it's currently set to the built-in sphere shape. So if we want to go just between sphere and none, you could write a rule using rule check, which will make a checkbox that you can toggle on and off. Okay, but what if we want more flexibility? Well, if you followed along with the cactus tutorial, you'll remember that we used rule combo to create a combo or drop-down box. So we can use the same thing here. If we want to toggle between none and sphere, we'll pass a table in with strings for their display names. And then in the rule body, we'll make a simple if-then statement. Here, I want to point out an important difference in regards to indexing. In the property bar, the indices start at 0. However, in the rules dialog, the indices of any combo box start at 1. So you'll need to account for those differences in your conditional statements. Okay, that's all well and good, but I want to have multiple custom shapes for my boxwood. That means I'll need to use the Enabled Geometry Forces option in the shape control settings. So when we turn that on, we see most of our model goes away. That's because we currently have no geometry forces enabled. To get this up and running, we need to add some forces. I've already loaded in some meshes for you, so to add them to your model, just go to the force icon, add force, geometry, and add each mesh. Now, although there is a built-in sphere for shape control, I'm going to load in my own sphere mesh so that I only have to toggle between the none setting and the enabled geometry force setting. Just adding the rest of them in. And we can see that with the Enabled Geometry Forces setting selected under the Shape Control tab, if we toggle each force now, it should fill the force mesh. Okay. So now, we'll only have to toggle between the None setting and the Enabled Geometry Forces setting. We'll also need to update our table of strings to include our new shapes, but I might end up needing more data connected to each shape down the line. If you followed along with the cactus tutorial, we made tables for each of our different shapes. So we can do the same thing here. Then I'll make a table to hold all of the shape variables. Next, I know I'll need strings for the display names that will eventually be passed into the prune shape rule definition. Also, it's good to note that the display name can be anything I want and does not need to match the name of my original mesh, the force, or the variable name. So for example, instead of calling the display name for my sphere, sphere, I've opted to call it round. Next, I'll need a table with all the display names. Okay, now I'll replace what I have here with the prune shape display names table. Then I'm going to copy and paste everything into the modeler, and our combo box with each shape appears. Hooray! However, of course it's not yet behaving properly because we need to update our rule body. Currently, our script is telling the modeler to go between the none setting and the sphere setting in shape control, which correspond to indices 0 and 1. So, because we want it to go to enabled geometry forces, we want it to go between 0 and 2 instead. Then we'll need to write a loop to cycle through each of the geometry forces, and choose the correct one based on our combo box. So to do that, we'll loop through the prune shape options table. So because the first option in my table is no prune and doesn't have a force, I'm going to start my loop at 2. Then, in order to toggle the correct force on and the others off, we'll need to use another function from the rules library, which is setPropertyEnable. We can use setPropertyEnable to toggle forces on or off. Like other set functions, after the generator name, we'll need to pass in the property we are setting. So for our rectangle force, for example, we can right-click and copy the name for the script. However, this alone won't do because we need to be able to swap out the name. So let's go back up to our shape tables and add in a variable to hold the force name. Also, while I'm here, I realized I forgot to add some commas, so make sure you add those. Now, another quick note about names. Earlier, I noted where naming doesn't matter, but this is where name matching does matter. You'll want to make sure that the name of your force in the modeler matches the variable here. So just be mindful that if you make a change to one, that you update the other. Now, for the no prune table, it currently doesn't have a force that it's referencing, but it will make our lives easier to keep our tables consistent. So what we can do is create a force and click the no specified mesh option. I'll name it no prune placeholder. Then I'll add the name to my script. Okay, so back in the body of our rule, we can now make this say shape.force. Then we can evaluate whether or not setPropertyEnable should be true for the current shape by checking if index is equal to the prune shape variable. And remember to close your loop. Right, let's copy and paste everything into the modeler. Now, a quick point for troubleshooting. If you're toggling between your shapes, but they aren't responding to the geometry forces, first check to make sure that shape control is only enabled on your trunk and no other generators. After that, if you're still having problems, make sure that all generators except for trunk have no geometry forces checked on. Okay, we're getting somewhere. We can now change how our boxwood is pruned with our rule. But we still have some funky things going on. As you're toggling, you might see something strange happen when you switch from a pruned shape to the no prune option. See, the trunk is bent. This is happening because the last shape to be selected still has its force influencing the model, even when shape control is set to none. So, there are a couple of ways we can correct this. One option is to move our loop outside of our conditional statements and change the index to 1. Another option is to keep the loop inside of the if-then statement and instead enable and disable the Allow checkbox under the Forces tab. Also, note that here we use setPropertyValue. Okay, I'm going to copy and paste that correction into the modeler, And we can see that that fixes our problem when we switch to the no prune option. But we're still not quite done with troubleshooting. See, if we toggle back to the pencil, we still have an oddly bent trunk. What's causing this? Well, if we go to the pencil force, we can see that the default force action is set to attract. If we set that to none, that keeps the trunk going upright rather than toward the wall of the mesh. So we'll want to change that setting for each of our shapes. Nice. Okay, let's do a quick save. So now we can move on to writing rules to adjust the size of our bush. Let's start with height. Now it's important to note that we'll need to treat our unpruned and pruned shapes a little differently. For no prune, we can easily use the spine length property. However, if we turn shape control on, you'll see that the spine length property isn't having any real effect. And that's because shape control is stopping the spine from growing past the mesh. So for our prune shapes, we'll need to indirectly influence how it grows by adjusting the scale of the forces. So for height, we can use the transform scale Z property of the force, so that it will end up looking more like this. Okay, I'll write my definition. Next, we'll need to write the conditional statement for our rule. Here, we'll need to reference which one of the drop-down options we want to modify. Remember that the indices of the drop-down menus start at 1, not 0. So when you want to compare no prune, for example, you'll want to set your conditional statement equal to 1. Now, when the prune shape variable is equal to 1, I'll use spine length to adjust the height of my model. I'm going to test the first half of our conditional, and that works. Now we just need to write the else statement in order to control our shape-controlled models. I'll copy the Z-transform property edit line from one of our shapes. It doesn't really matter which one. And paste. Okay, so right now, this set line is functioning on rectangle. Now, we need to pass in the name of the force based on which shape we have enabled. So like how we have equals rectangle here, we will need to switch that out with sphere or pencil or whatever other shape you have in your menu. There are different ways to achieve this. For example, I could create a variable in our shape table that has that string. Or we can write a helper function to extract the force name from the force variable we already have. So I'll do that down here. We can use the Lua function match to find the correct part of the string. Then we can call the function and pass in the current shape. To get the current shape, I could reference the area like this, but it's a little cumbersome. So, although it's generally not best practice to use global variables, for scripting rules in SpeedTree, the script is so self-contained that it generally won't be a problem. So I'm going to go ahead and make a variable called current shape and initialize it. Then I'll put a line in the main function to make sure that it updates. Finally, I'll pass it into our helper function. Next, we'll need to determine the values for our lerp statement. I could have the same values applied for each shape, but I want to be able to specify different max and min values depending on what shape. So, I can make variables in my shape tables for min and max height. Okay, so I'm going to test out which values I want to use. And while I'm figuring that out, you might notice that my bush doesn't always fill up the entire mesh. Don't worry about that, we'll fix it in a moment. Also, for now, so that I can get to testing more quickly, I'm going to simply copy the same values for each shape and adjust them later. Right now, we'll go ahead and replace our placeholders with currentShape.minHeight and currentShape.maxHeight. Then update any other placeholders. Okay, let's paste all of that in. And it looks like min and max heights are working properly. Now let's make sure the whole model fills the force. To do that, we'll need to make sure the trunk is tall enough. So what I can do is add a trunk height variable for each shape to ensure the trunk is always tall enough to meet the requirements of the force's max height. But a word of caution. If we start scaling up the trunk, the poly count on our leaves and twigs can shoot way up all of a sudden and slow us down if we're not careful. So I'm going to temporarily reduce our big branch frequency as a precaution. Now we can increase the length of our trunk until it hits the top of the mesh, or goes past it. It looks like 10 will do the trick. It also looks like we need to adjust the branch boundaries in a minute. Okay, so back to our script. I decided I want a taller max height for my rectangle, so I'm going to change that to 5. Then I'm going to make a trunk height variable and set it to 10. For now, I'm going to just copy and paste that for the other shapes as well. However, for the no prune shape, the max height and the trunk height values are actually referencing the same property, spine absolute length. So I'm just going to set trunk height equal to max height. Okay, now make sure you add your commas after your variables. Then, in the body of our rule, we'll just add a line to update the trunk height based on our shape. And copy and paste everything into the modeler. Okay, now let's quickly fill in the bottom of the trunk. We just need to adjust our big branch's first boundary closer to 0. And I'm going to up the frequency a bit more, just to get a better idea of the fill. Alright, now when I go to test my height, we can see that the trunk is still doing some funky things, and we're getting this weird flickering. If I turn off the leaves, I can see that sometimes the trunk is bending in this weird way that we saw earlier. What's causing this is the force's collision behavior. The collision behavior is set to obstruct. So when the trunk hits the force, it tries to navigate the surface. Now that won't do, so what are our other options? The prune option chops off geometry where it hits the force. This seems like an option that could work, but if we drag our height slider, we can see that our branches are pointing upward in a way that they weren't before. This brings up an important note about the prune option, which is that we need to make sure the bottom of the generator the force is applied to is totally inside the force. So I need to drag down the force to make sure that it's not clipping the bottom of the trunk. And when I do that, our branches return to normal. If you need to, you can reduce the size of the indicator scale to see better. So prune looks pretty good at first, but again, if we scale down our height, it doesn't work super well. We have this weird open pocket up at the top. Even when we increase our branch frequency, it's still sparse. So I'm going to undo all of that. Okay, what's our last option? The collision behavior we want to use is stop. This setting stops the trunk where it hits the force, but it treats the leftover geometry like a full-length branch. Now, we just need to increase the frequency of our big branches to fill in everything. Now, if you're not seeing your model, like the prune collision behavior, the stop behavior also requires you to drag down the force. We'll repeat that process for the other force meshes. Okay, just testing to make sure everything works. That looks good. We can now move on to the width and length rule. So their definitions will look something like this. Then we'll do the same thing that we did for height and find minimum and maximum width and length values for each of our force meshes. Now, the no prune shape is again a special case because it doesn't have the same properties available, by which I mean the x and y scalars. So for now, I'm just going to put zeros as the default. Okay, go ahead and add in the rest of the variables. Then we write the rule bodies similar to the height rule. However, you'll notice that I'm not writing an if-then statement. Why? Well, because the no prune option doesn't have a geometry force, there isn't a super efficient way to discretely control the length and width of the unpruned model. As a quick aside, if you did want to do that, you could set up multiple sets of generators, place them in 4 different quadrants, using a combination of the sweep and rotation properties, and control the sets on opposite sides together so as to control the x and y of the bush individually. However, to keep our generator set up simple, I'm just going to denote the width and length sliders as prune only. Okay, let's go ahead and test those 2 rules out. I'm also going to tweak my frequency again. Okay, I'm just going to make some adjustments to my min and max variables. And now just testing. Okay, I'm liking how that looks. Now let's do a bit more refining. First, when my model is really tall, my poly count is quite high. But when my model is short, I need more branches to keep the bush looking nice and fluffy. So to balance this out, I'm going to add a couple of lines to interpolate the frequency of the big branch generator from, say, 10 to 30 relative to the height. So when my model is shorter, I'll have a higher frequency of branches, and when it's taller, a lower frequency. Next up, when I look at my pencil shape and photo reference, I see that the trunks of the bushes are somewhat visible at the bottom, which I'd like to reflect in my model. But if I want to copy that look, remember that I can't just drag the force up to reveal some of the trunk because we're using the stop collision behavior. And the bottom of the trunk needs to be inside the force. So what I want to do is create a base trunk for my current trunk generator to sit on. So I'll copy my trunk generator and paste it to the tree generator. Then I'll attach my original trunk with all the children to the new base. Now you'll want to make sure that it's an extension. So make sure that gen extension is set to any, and then set your old trunk to have an absolute number of 0 to kill off any extra trunks. Next, I'll reduce the length of my new base trunk to something quite short like 0.5. I'll also rename the generators to something like base trunk for the one on the bottom and main trunk. Now I just need to update my shape control and force settings. I'll move the force up so I can see the base trunk, and I'll turn off shape control and any forces on that generator. I still don't see my full model. The reason why is because I changed my generator name from trunk to main trunk, and currently, everywhere in my script that I have trunk has an equal sign in front of it. As a reminder, the equal sign means the statement only acts on generators named exactly trunk. For my purposes, I know that anywhere that I have equals trunk, I want that line to act on the main trunk now, so I'll just refactor and replace all those instances at once. Then we'll copy and paste to the modeler, and we might just need to move our force down a bit so the bottom of the generator is contained. Next, I'm going to increase the radius of my base trunk because it's super skinny right now. And I'm getting some strange pinching. So first I'm going to take all the radial displacement out of my main trunk. Then I'm going to adjust my base trunk skin profile curve, increasing the right point to keep it from tapering off, and making sure the left point is equal to the base value. Like I mentioned before, your model might have original settings you need to tweak as you set up your rules. I'll just make a few more adjustments. Next, if we switch to scribed mode, our trunk looks very low poly. But that's because I'm currently working in low resolution. If I switch to high, I'll get a more accurate read on my segments. So I can make some adjustments if I want to. And now I'm going to go back to low after I make my changes. Next, I need to fix my roots. So I'm just going to attach them to the base trunk and adjust the boundaries and radius as needed. Now I'm going to check my other shapes and adjust the force placement and tweak the roots accordingly until I'm happy. It looks like my pencil needs a little bit more filling in, so I'm just going to make an adjustment to the branch frequency lerp in my height script. Okay, we've put a lot of work into those first few rules, and it's shaping up nicely. Now let's work on the rules in our leaf section. Now, if we switch our model back to high resolution, it's still in an acceptable poly count range for VFX, but it is a little bit high. One of my favorite new features to help reduce this number is shade pruning. It's super handy because it can remove leaves and twigs in the interior of the model while leaving the outer silhouette intact. To use it, we'll first need to enable it in the toolbar. Then we'll configure the settings in the Post tab of our leaf generators. In the Post properties, set the style to interior. And you can see that greatly reduced our final poly count. We can scrub the threshold to change the strength of the pruning as well. So for our rule, I just want to be able to control the threshold property. That means it'll look pretty much like a normal rule, both in the definition and the body. Notice that I did remove the equal sign from the line I pasted in. And copy and paste. I'm going to test going between 0 and full strength. Okay, looks good. Next, I'm going to create a rule called pockets to carve out random sections of the bush and create a more organic visual look. You could play around with a variety of different properties, but a good starting point is to use some combination of knockout and spine break. So I'm going to use knockout on my first set of big branches And I think I'll apply some spine break to my second set of big branches. Okay, I like how this looks. And my final rule looks like this. Now I can test prune interior and the pockets rule together. I'm happy with that for now. Okay, last in our leaves section, I want to write a rule to control the leaf density or sparseness. That's going to be pretty simple. I just need to adjust the knockout property on the leaves. One unique thing though is that because I want my leaves to be at their most dense when the slider is at 1, in my lerp statement, I'm going to replace leaf density with 1 minus leaf density. And this will reverse the behavior of my slider. Next, I'm liking how the canopy of my bush looks, but my trunk in the middle still looks a bit sad when you can see it. To create a little bit of interest, I think I'd like to add some bare branches to it, but I'd also like to have the option to hide them in case I don't want the extra polygons. So first I'll need to make some bare branches. You can make them yourself, or if you go up in your generation window, you can grab the set that I've already made for you. Just drag them onto your main trunk generator. Then for our rule definition, I'll use rule check, and I'll set the default to false. Then in the body, I'll use set visible to hide and show the trunk twigs generator and its children. Looks good. Alright, next I'd like to have a rule to adjust the trunk width. Now this rule should be pretty simple, but just note that your maximum width will be limited by your geometry force mesh. So what does that mean? Practically, if you make your trunk radius so big that it no longer fits inside the force, your model will disappear. This is most likely to happen with the pencil force because it's narrow at the bottom. So to set up some guardrails, I'm just going to scale down my meshes using my rules and find the maximum width that I want to allow for each shape. And then I'll store that in their respective tables. You could get even more specific about your limiting factors if you wanted to, but this is a good baseline for now. Okay, then we'll write our rule body and test it out. That's looking pretty good. Okay, we're almost done. Before we write our last rule, I'm going to just hit reset to defaults. And that looks pretty rough, so I'm just going to adjust some of my default values in the rule definitions. Okay, that is much better. Finally, we're on to our last rule. This last one I'm going to call maintenance. For this one, I want to write a rule that will change how neatly pruned or overgrown the model is. So we can do this by using a combination of the stop shape control property and adding variance to the length of our branches. As a reminder, we have to stop shape control in order to use the spine length properties. I think I'm just going to modify the settings on my second big branches generator. For the type of rule, we could use a regular rule with a slider that adjusts the amount of variance, but I'm going to opt to use rule combo so that I can name the specific options. In that case, I'm going to do the same sort of thing that we did for the prune shapes and make tables to configure the different styles. For my styles, I'm going to make my options neat, natural, and overgrown. For each option, first I'll have a display name, then I'll have a Boolean value that states whether stop shape control is true or false, And then I'll have a variable that holds the amount of variance that the style will have. Since the neat style will have shape control on, we can set its overgrown amount or variance to 0, since shape control will negate any effect. Adding in the other tables. Then I'll have a table with my maintenance style options and a table with the display names. Then in my body, I'll have a set property value line to either turn on or off stop shape control. Because the property is stop shape control, I've added a not operator here. Then I'll finish with a set property variance line. Let's copy and paste to test. And it looks like it works. Remember, this is just a starting point, so feel free to add more controls if you'd like. And with that, we are done! Now comes the most fun part, playing with our rules. I hope you've enjoyed this tutorial. Thanks so much for watching, and catch you in the next one. Bye!